Welcome back to Geometry. We're at section 11.2, surface area of prisms and cylinders. For the first time this year, we are now dealing with 3D shapes. So let me grab my pen here. And so we now have a 3D shape. This is what we see down below. And for the first term, we're going to ignore this first term and just focus on prism. So prism is a 3D figure with two congruent and parallel bases. The base can be any type of polygon. However, lateral faces, let's continue this. So we can say that a prism is a 3D figure with two congruent and parallel bases. Let's put bases plural. That can be any type of polygon and lateral faces that are parallelograms, rectangles, and squares. So what we're saying here is that our shape to the right, in this shape, our bases have to be triangles. Now, that's important, and the reason why is that we're told that lateral faces have to be parallelograms. So in this shape, we have two shapes. We have a rectangle, which is what this shape is sitting on. Okay, but when we deal with 3D shapes, we have to be able to flip shapes around. So when I look at these two triangles, and they're both right triangles, here's one and here's our second one, these are actually our bases. Even though the shape is not sitting on these two triangles, these two triangles are in fact our bases. And again, the reason being is that we're told that lateral faces have to be parallelograms, which means rectangles and squares. And we actually have three lateral faces. We have one on the bottom, we have two on the side, and then we have our third one that's in the very back. Okay, so if we were to just look at this shape, we have three rectangles and we have two triangles. Okay, and that's going to factor in how we find lateral area, surface area, and then later on when we find volume. We name a prism by the shape of the bases. And so the name of this prism up to the right is going to be called a triangular prism. And the reason why it's called a triangular prism is that the bases are triangles. Next, the shape to the left. Alright, well, let's do this. I'm going to, in green, highlight first our height. And actually, let me jump back here. Let's define our height in this first problem. So we see that the height is going to be the perpendicular distance between two bases. So I know that most of you will think the height is 15. It's not. Okay, the height is going to be 25. And the reason why the height is 25 is that it's the length between our two bases. And so this 90-degree box right here, it looks like it's formed by this triangle, but really it's being formed by this base that's our rectangle and this triangle. So I like to think of height as the length between our two bases, and then of course it'll form 90-degree angles, and so our height in this problem would be 25. Our height in this problem, I'm going to highlight, we have four heights, and over here we had two heights. We had this height and this height. Sorry, we have three heights. So this is a height, this is a height, and this is a height, and all of those lengths will be 25 meters and 25 meters for these three lengths. In this shape, I'm highlighting our four heights. Okay, and so all of these are heights, and I guess I'll go ahead and label all of these as such: H, H, and H. Alright, and they want us to name the shape. So we want to look at the base. The base in this problem, let's highlight the base, and here's our base, and this base is a trapezoid. I'm not drawing very straight today. So this is a trapezoidal prism, and it's asking for its lateral area, or what is lateral area. All right, well, lateral area is the sum of all lateral faces. So before we answer this question to the left, let's go back to the first shape that we had up here. We had 3 rectangles. Okay, so if I were to define lateral area, I would find the area of each rectangle. So this would be our lateral area in our first shape for the triangular prism. We would find the area of each rectangle, and then that would be our lateral area. So when I look at this shape down here below to the left with our trapezoidal prism, we have 4 rectangles. 1, 2, 3, 4. Okay, so we need to find the area. So we're going to find the area of our 4 rectangles. Okay, and how do we find the area of our 4 rectangles? Well, we know that area of rectangles is going to be base times height. Okay, so as I look at this shape, I have the area of our top rectangle, so I'm going to put A for T. We're going to find that area. We're then going to add up the area of the rectangle on the right hand side of the shape. We're going to add up the area of the bottom rectangle, and we're going to add up the area of the left rectangle. Okay, so let's do that now. The area of this top rectangle, and actually before we do that, let's label some more sides. Let's call this length D. We're going to call this length up on top A. We're going to call this length at the base C, and we're going to call this length right here B. So the area of the top is going to be the base times the height. That's going to be A times H. And so I will show this as A times H. Plus the area of the right rectangle will be B times H. Plus the area of the bottom rectangle, which is going to be C times H. And then the area of the left rectangle, which is going to be D times H. Now, as I look at what I have here, I see that they all share an H in common, H, H, and H. So I'm going to pull an H out, and then underneath I have, or inside I have A plus B plus C plus D. Alright, well H stands for the height, okay, and I can clearly see that. When I look at A plus B plus C plus D, well, A plus B plus C plus D, this is going to be the base perimeter of our base. Here's our base, and when I add up all these sides, A plus B plus C plus D, that equals the perimeter of our base. So I'm going to put P, and I guess let's just write it out, perimeter of our base. Okay, so this becomes our formula to find lateral area. We are going to say that LA, which stands for lateral area, is equal to our base perimeter multiplied by the height. Okay, so this is a formula that we need to know, and we can fill that in below. So lateral area is going to be the area of all lateral faces. It's going to equal the height of the prism multiplied by the perimeter of the base. Alright, next, and so again, lateral area is going to be faces only. It's the lateral area of each face. So faces only for lateral area. Alright, when we go to surface area, now we're going to find the area of faces and bases. That's right, it rhymes. You heard that here first. No other book will show you that. So the surface area is going to be our lateral area, which is our area of all of our faces plus the area of our bases, which would be 2 times our base area. And so that would be shown as surface area equals lateral area plus 2 times the area of our base. Alright, we're going to keep moving. The example, or the prism below, we look and we see all rectangles. So this is going to be called a rectangular prism. We're then going to enter everything in, decide which face is the base. In some cases there's more than one choice. And so I'm going to let this shape be our base. So we're going to say that the base of the rectangle is 2 feet by 3 feet. Our perimeter, that means this is 3 and this is 2, would be 10 feet. And the height is this distance between our two bases, which is going to be 6 feet. Now, lateral area is equal to our base perimeter times height. So lateral area is equal to our perimeter 10 multiplied by the height, which is 6. And so that gives us 60 feet. To find the area of the base, it depends on the shape of the base. In our drawing, the base in our figure is a rectangle. The area of a rectangle is base times height. And so the area would be 2 times 3. Area is equal to 6 feet squared. Alright, we're going to continue over to the next page. Alright, we're back. We're going to identify this shape of the base. And so, again, we're back to our triangular prism. So the base is a triangle. Therefore, the name of this shape is going to be a triangular prism. We're asked to find the perimeter of the base. Now, we have an 8 and we have a 15. I'm going to put C here for this length. And the reason why it's C is because since this is a right triangle, we can say 8 squared plus 15 squared equals C squared. C is going to be 17. So our base perimeter is going to be 17 plus 15 plus 8, which would give us 40 meters. The height is going to be this length here. It creates a 90-degree angle. So here's our height. We have 3 heights in this shape, just like we have 2 bases. So the height is going to be 8. Our lateral area is going to be our perimeter. And so actually let's do this first. Let's put P times H. And so lateral area is going to equal 40 times 8, which is 320 meters. Alright, formula for the base of a triangle is going to be 1/2 base times height. So the area of our base is going to be 1/2. Our base is 8. Our height is going to be 15. That gives us 60. That gives us 60 meters squared. Surface area equals lateral area plus 2 times the area of each base. And so our lateral area, that would be 320 plus 2 times 60. So 320 plus 120, that gives us 440 meters squared for the lateral area. Alright, next shape. We have a trapezoidal prism. Our base are trapezoids. Now in this shape we have some measurements that were left off. So draw down this height. This is going to, you would be told that the height is 4. This creates a 90-degree angle. You would be told that this side is 5. Draw down a second height. It's also going to be 4. And you know this is also going to be 5. Which means if we do a squared plus b squared is equal to c squared, we know this length right here will be 3. And this length right here will also be 3. You would also be told that in this shape that this length is 6. And this shape will be 6 as well. And then you would also need to be told that our height is going to be 8, and there's Alright, to find our perimeter of the base, we have 3 plus 6, 9, that's 12, plus 6 is 18, plus 10 is 28. So we have 28, and I guess let's go units. What is the height? The height is going to be 8. So our lateral area, the area of our faces, will be our perimeter, 28 multiplied by 8. And so 28 times 8 would give us 224 units squared. The area of the base, we're going to say 1/2 height, B1 plus B2, that's for a trapezoid, so 1/2, 8, and then 6 plus 12, and so that would give us 36 units squared. Our total surface area will be lateral area plus 2 times the area of our base. So the lateral area is 224 plus 2 times 36. So that gives us 296 units squared. Alright, rectangular hexagonal prism. Now this is exciting. Alright, I'm glad our notes think so. Identify the base. Our base is a regular hexagon. So right off the bat, we know that to find the area of a regular polygon, it's going to be area is equal to 1/2 a times p. So in this shape, let's draw down our apothem that creates a 90-degree angle, and then draw down the radius. So this is going to be r, this is a for apothem. And then if this whole length is 6, we know all of these are 6. 6 is all the way around, but then this would have to be 3 and 3. Okay, so at some point in time, to find the area, I'm going to have to solve for this triangle. I have a for the apothem 3. We have a 60-degree angle down here, 30-degree angle up on top. How did I know that 60 degrees was down here? Well, all of these angles are 120 degrees. So this angle is going to be cut in half by the radius, so this angle has to be 60 degrees. Alright, our base is a regular hexagon. If we were to find our perimeter, we'd take 6 times 6, that's 36 inches. The height is going to be 10. Our lateral area is going to be 36 times 10, which is 360 inches squared. The formula for the area of the base is going to be 1/2 lowercase a times p. So 1/2 the apothem, in this case, is if I move from a short leg to a long leg, I would get 3 rad 3. So I have 3 rad 3, and then multiplied by the perimeter, which is 36. And so that would end up giving me half of that would be 18. That's 54 rad 3 inches squared. Surface area is going to be lateral area plus 2 times the area of our base. So lateral area is 360 plus 2 times 54 rad 3. That gives me 360 plus 108 rad 3. These aren't like terms, so we'll leave it as such. 360 plus 108 rad 3. Alright, we're going to go to our last page. Alright, we're to our last page of notes. We're now dealing with cylinders, and we will solve cylinders the same way that we solve prisms. So everything's the same except the bases are not polygons. Alright, the bases in a cylinder, as we can tell, are circles. Alright, but we still solve it the exact same way. So for lateral area, we're still going to use the perimeter times height. For surface area, it's still going to be lateral area plus 2 times the area of the base. So what's nice about cylinders is same exact formulas as prisms. Okay, so that makes it easier on us to remember, hey, we just use the same formulas that we use on a prism, we use on a cylinder. So circumference of the base is going to be 2 pi r. So we have radius of 10, so we get 2 times pi times 5, and that gives us 10 pi. The height in this problem is going to be the distance between our two bases. That's going to be 24 feet. So I have 10 pi times 24, and that gives me 240 pi feet. To find the area of a circle, we use pi r squared. So that's going to give me pi times 5 squared. That gives me 25 pi, and it'll be feet squared. surface area is going to be lateral area, which we found to be 240 pi plus 2 times 25 pi. And so multiplying that out, we're going to get 240 pi plus 50 pi. And these are like terms, so we get 290 pi feet squared. Thanks for joining us. See you next time.